In the previous two videos we looked at and then repaired the EP102 printer from this Burroughs C-6202 calculator. I'll put a link to those videos down in the description. This time round we'll look at the calculator itself and work our way through its pre-programmed applications to see how useful they'd have been back in 1973 when this machine was new. If you want to skip straight to the demonstration section, I'll put chapter links down in the description, and if all you're interested in is the advanced program features of the machine, I'll put a timestamp up on screen about now so you can just skip to that part. Burroughs had been making mechanical calculators and adding machines since the early 1900s, or technically the late 1800s if you include their former name of the American Arithmometer Company. I did a video a few years ago looking at this Class 8 machine dating from somewhere in the 1920s. As time went on, the machines became faster and more complex, often being powered by electricity rather than having to crank a handle. I don't have an electromechanical Burroughs machine, but this precise machine is the kind of thing we're talking about. By the late 50s, Burroughs were making large accounting systems, like this F1000 alphanumeric accounting machine. I wonder if there are any of these still in existence. I bought this brochure a few years ago because it just looks so amazing. By the 1970s, if you were a calculator manufacturer, you either gave up or you started making electronic machines, because pretty soon the mechanical calculators would be a thing of the past. The early electronic machines were large and relatively basic, but rapidly gained extra features and reduced in size. My Burroughs C-6202 pre-programmed calculator is a printing calculator made in France in 1973, or thereabouts, and it's very much aimed towards financial work. I saw an advert for this machine saying that all its extra programmed features would only cost a few dollars more than a standard calculator, and it could eliminate over 50% of the work. So what can it do? Well, obviously it can add, subtract, multiply and divide, that's a given. But you do have to do it in the correct way. If I'm adding 1, 2, 3 plus 4, 5, 6, I need to enter 1, 2, 3 and press the plus button, followed by 4, 5, 6 and plus. That adds both amounts into the register. And to see the result, you either press the subtotal or total key. The difference being that the subtotal leaves the answer in the register ready for more calculations, whereas pressing the total prints the answer and clears the register ready for a new calculation. Subtracting works in the same way, whereby you enter the number you want to subtract and then press the minus key. Multiplication and division are more like the way you'd use a pocket calculator. So if I want to multiply 886 by 7, then I simply enter 886 times 7 and press the equals key, which is shared with the plus key on this machine, and we get the answer of 6202. You'll see that it has an asterisk next to the answer. This shows you that it's a total and the register is clear for the next calculation. For example, if I now press 7 and plus, followed by the total key, I just get the answer of 7 because the register had been cleared after that multiplication. If I wanted to use the result of that multiplication, so I'll just re-enter it, 886 times 7 and press equals. I just have to press the plus key again to add it back into the register. Now I can add my 7 and plus, followed by the total key, to give the more expected answer of 6209. Division is more or less the same as multiplication, so we don't really need to look at that now. The percent key works in a slightly different way to the similarly aged Adler calculator that I featured in a previous video. Let's say I want to add 20% tax onto an item costing £127.50. Then I just enter my 127.50 times 20%, which will show me the original amount of £127.50, the percentage of 20%, and the amount of tax at £22.50. Then all I have to do is press the plus key and it'll add the tax onto the original amount to give £153. That's one more keystroke than on the Adler, but if I wanted to offer a 20% discount on my £153, it's slightly easier, or at least it seems a bit more logical to me, because all I have to do is enter my £153 times 20% and press the minus key to get the result of £122.40. On the Adler I needed to use the change sign key so I was multiplying by a minus percentage, like this. 153 times 20, change sign, percent, and then the equals key. As we've just seen, the change sign key allows you to multiply by a minus figure. So if I want to multiply minus 4.7 by 3.45, I can enter 4.7, change sign, times 3.45 and press equals, to give the answer of minus 16.22. And you'll notice that all minus values are printed in red. The DS key allows you to set the number of decimal places from 0 to 9. By default, when you turn the machine on, it's set to 2. But if I want to change that to 4, I simply press 4 and DS, and now everything will be shown rounded to 4 decimal places, and it prints 4D on the paper to remind you. So if I do the usual 355 divided by 113, we get the answer of 3.1416. If you latch down the floating point key, which is all the way over here, the machine works in floating point mode, ignoring whatever setting you have for decimal places. So if I set the decimal places to 2 and latch the floating point and enter 9.75 divided by 7.9 and press equals, we get the answer of 1.234.177.215.1898. We can use the constant key if we're going to be multiplying or dividing by the same number repeatedly. Say for instance that I'm converting a load of imperial measurements into millimetres. I can latch the K or constant key, then enter 25.4 times and my first measurement of 3 1/4 inches, or 3.25, and press the equals key to get the answer of 82.55 millimetres. And then I can enter my second measurement of 18 inches and press the equals key to get the answer of 457.2 millimetres, and then maybe 8 3/4 inches to give the answer of 222.25. And I can carry on doing this for as long as necessary, only having to enter the multiplier on the first occasion. The same can be done with division, so if I unlatch and relatch the K key, which clears the previous constant, then enter 55 divided by 4.546 and press equals. This time it's the divisor of 4.546 which is the constant, and we get the answer of 12.10. And again I can just enter my next amount of 79 and press equals to get the answer of 17.38 without having to enter the divisor again. If I want to accumulate all the results from constant multiplication or division, I can use the grey memory plus key over here rather than the plus equals key. This adds all the results into memory 1. So I'll enter a few more randomly selected numbers, and then we can recall that total by pressing the memory subtotal or memory total key. Like that. The C key clears the keyboard without adding anything into the register. It also clears the machine if you've made an error, such as pressing 2 keys at the same time or the register has overflowed. At which point in time a red light will come on over here. I'll dim the studio lights so it's easier to see. And if I press the C key, it goes away again. Theoretically, when the machine is operating normally, this light should be green, but the green bulb has blown. I'll get round to replacing that sometime. And lastly, before we start looking at the special programs, you've got the memory keys over here. Plus to add something into the memory, minus to subtract, memory subtotal and memory total, which also clears the memory after printing the total. By default you'll be using memory 1, but there are actually 5 memories. To access the others, you first have to press the M button, followed by the number of the memory you require, followed by the memory plus minus subtotal or total key as required. At any point in time you can show the totals of all 5 memories by pressing the M star key, which will list all the memory totals. However, as these are totals rather than subtotals, it will also clear the memories, so it'd be kind of annoying if you hit this one by accident. You would at least have the printout to look at, so you could re-enter your data, but it would still be frustrating. So finally, the big moment you've been waiting for. What do these pre-programmed modes do, and how do you use them? I was lucky enough to get a partial manual with this machine. It's a photocopy of a photocopy, and it's really difficult to read in places, but it made figuring out the programs much easier than it would have otherwise been. Here's a list of the 8 programs showing the typical applications for each. You can pause the screen if you want to examine it in more detail. Starting a program is really simple. You just enter the program number and press the P key. So we'll go for program 1, which calculates the selling price from the cost and the gross profit margin percentage. Gross profit margin not to be confused with markup. Markup is a percentage of the cost price added onto that cost price, whereas the gross profit margin percentage is the percentage of the final selling price that is profit, which is a little trickier, but not all that tricky to work out. So I'll start the program by pressing 1 and P, and the calculator prints out the totals of all the memories. This ensures they're cleared before starting the program, and also gives you a printout of what was held in those memories in case you need that later. The 5 memories form an essential part of many of the programs in this calculator. And now we're ready to start inputting our data. So let's imagine we have 3 new products that we're going to sell. Item number 1 costs us £40 to make, and we operate with a 55% gross profit margin on our own manufactured goods. First we enter the percentage of 55%, followed by the cost of £40 and the plus equals key. Item number 2 costs us £128 to make, so as before we enter the 55%, followed by the cost of £128 and the plus equals. Finally, item number 3, and this item we buy in from another supplier, and to keep the sale price keen we operate with a smaller gross profit margin of 45%. So we enter the 45%, followed by the cost to us of £76, and press the plus equals key. And then follow that by the M* button. So if I just tear that off, we can have a look at the results. At the top we have the previous totals from the 5 memories. In this case they were already at 0, but they get cleared just the same. You'll notice that we've got memory 1, memory 2, memory 3 and memory 4, and then the last one is just blank. Presumably they ran out of spaces on the drum for the number 5, so you just have to remember that the one with no number is memory 5. Next it shows us that we're in program 1 before printing the results. So for item number 1, it shows the 55% gross profit margin, the £40 cost of the item, and the sale price of £88.89. Item number 2 has the same 55% gross profit margin, the cost of £128, and the sale price of £284.44. And last but not least, item number 3 has the smaller percentage of 45%, the cost to us of £76, and the sale price of £138.18. Beneath that we have the combined cost of all the items at £244, and the combined sale price of all the items at £511.51. And at the bottom, the count of 3. This count would be more useful if you had a big list of items to analyse, so you could quickly check that you'd entered the correct quantity. We can of course work out the selling price from the cost and gross profit margin percentage by taking the cost, we'll use the £40 for this example, and dividing that by 1 minus 55%. Or to express that as a decimal, 1 minus 0.55, which of course equals 0.45. So our £40 divided by 0.45 gives us the answer of £88.89. The program just makes things a little easier and adds the bonus features like cost and selling price totals along with the item counter. Right, I'll try to rattle through the rest of the programs in a little less detail so you can get a rough outline of what they do. Program 2 calculates compound interest and prints the results with automatic scheduling of each payment. It can also be used to calculate depreciation, but we'll go for compound interest for this example. So I'll press 2 and P, and the machine goes through the usual procedure of clearing all the memories. And now we're ready to input our data. So let's say we're borrowing £25,000 over a period of 10 years at a rate of 12.5% per year. In this example, the interest is compounding annually. If it was compounding monthly, the percentage would be divided by 12 and the duration multiplied by 12. First we enter the duration of 10, followed by the minus key, then the percentage of 12.5%, followed by the percent key. Then press times, and finally enter the principal amount of 25,000 and press plus equals. The calculator will then print out the current amount of the loan and the interest for each year. Once it's finished doing that, you press the M* key to print the totals. So I'll tear that off, and as before, we have the contents of the memories at the top, followed by the program number. Beneath that is the duration of 10 years, and the percentage expressed as a decimal. You can see that it's entered that as a constant because there's a K next to it. And the total amount borrowed is also shown. Then it will rattle down the years, showing the interest and total amount for each year, until we get to the totals at the bottom. So the overall amount payable is £81,183.04. The principal amount was £25,000, and the interest amounts to £56,183.04. At first glance, these printouts appear to be complicated and difficult to understand, but you soon get used to them, and it's easy to make notes or highlight areas as you go along, ready to transfer that information to the customer records or whatever. Program 3 can be used for a number of similar applications, but we'll go for proration. So I'll start up the program with the usual 3p, and we're ready to go. So let's assume we've got 4 sales reps who've bought in £29,000 of work this month between them, and we have a £5,000 bonus to pay out based on the amount of work each rep bought in. So we'll enter 5,000 divided by 29,000 times, and then the sales figures for each rep. Sales rep 1, 4,800, followed by plus and equals. Sales rep 2, 12,975 and plus and equals. Sales rep 3, £8,498, followed by plus and equals. And finally sales rep 4, £2,727, followed by plus and equals. And finally press the M* to get the totals. Looking at our printout, we can see our initial figures of 5,000 and 29,000. Then for sales rep 1, who bought in £4,800 of work, they get £827.59. Rep 2 gets £2,237.07. Rep 3 gets £1,465.17. And Rep 4, who only works part-time, gets £470.17. And then at the bottom we can cross-reference that all the bonuses add up to £5,000, and all the money bought in adds up to £29,000. And finally that we've analysed 4 lots of data. OK, on to Program 4. I'd be really interested to hear from anyone who used one of these Burroughs pre-programmed machines and find out how many of the programs they actually found useful, because some of them seem to be a bit more niche than others. Anyway, for Program 4 we'll try this example. Say we're working on several building projects. For project number 1 we used 10,872 red bricks costing 30p each, so I'll enter 10,872 times 0.3 and plus and equals. For project number 2 we used 4,150 blue bricks costing £1.20 each, so that's 4,150 times 1.2 and plus and equals. And for project number 3 we used 22,800 grey bricks costing 98p each, and then press the M* key as usual. So, looking at the printout, we can see the cost of the bricks for each project, here, here and here. The average brick cost at 81p. The total cost of the bricks at £30,585.60. the amount of bricks used, which was 37,822, and finally the number of lines we've analysed at the bottom. I'm sure I could have come up with a better example for that program if I'd tried hard enough, but I'm sure you'll get the idea. So, on to program 5. Only 3 more after this. Among the applications for this program is sales analysis. Let's say we have 3 shops and we want to analyse last month's sale figures compared to this month. The program is launched in the normal way, entering 5p and waiting for the memories to clear. And now we can enter our data. Shop 1 had a turnover last month of £9,823, so we enter 9823 and the minus key. And this month's turnover is 11,262, followed by the plus equals key. Shop 2 was £12,436 last month, followed by the minus key, and £9,221 this month, followed by plus equals. Finally, Shop 3 was £7,389 last month, followed by minus, and £8,024, followed by plus equals for this month. And as normal, we finish off by pressing the M* key to get the totals. And looking at our printout, we can see that Shop 1's sales increased by £1,439, which equated to a 14.65% increase. Shop 2 had a bad month, making £3,215 less than the previous month, or a 25.85% reduction. And Shop 3 increased its sales slightly by £635, which equated to an 8.59% increase. Total sales last month were £29,648 and this month £28,507, which gave an overall reduction of £1,141. And you can see that we analysed 3 sets of figures. With Program 6 we can look at growth over succeeding periods. The program is launched in the usual way and then we're ready to enter our data. So let's imagine we're looking at the number of subscribers on a YouTube channel to see how well it's performing. And these are all made up figures, of course. We'll start off at January with 1143 subscribers. So I'll enter 1143 and press minus. Then February with 1389 and press plus and equals. Then March with 1703 and press plus equals. Then April with 2057 and press plus equals. May 1872 plus equals. And finally June 2001 and plus equals. There's no need to press the M* button with this program because it's not using the memories. So if we look at our printout, we can see that February gained 246 subscribers, which was an increase of 21.52%. March gained 314 subscribers, or 22.61%. April increased by 354, or 20.79%. And then May came along. That must have been the month that we released a really long video showing how an old calculator operated. That lost us 185 subscribers, or minus 8.99%. And finally June gained 129, which equated to an increase of 6.89%. Good news, we're on to Program 7. There's only 8 programs, and Program 8 is pretty simple, so we're nearly done. Program 7 basically allows you to work on 2 lists of numbers at the same time. For this example, let's say we have a stall that sells ice creams and cakes, and we want to add up the daily totals for each product line. So, with the program already launched in the normal way, we can enter the figures for day 1. So that's £320 for ice cream and press the plus equals, followed by £72 for cakes and press plus equals. Every time the plus equals is pressed, the calculator automatically swaps between memory 1 and memory 2. So for day 2, ice cream sales were £407.50 plus equals, and cakes were £84 plus equals. Day 3, ice cream sales were £437.50 plus equals, and cakes £112.50 plus equals. Day 4, it must have rained because the ice cream sales were down to £195, plus equals, and cakes were up to £234, plus equals. And finally for day 5, ice cream was £370, plus equals, and cakes were £190, plus equals. And then press the M* key to get the totals. So we've got the totals for each day, followed by the weekly total, which for ice cream was £1,730, and for cakes was £692.50. And as normal, it shows the number of days we've entered data for at the bottom, that being 5. OK, you'll be very pleased to know that we've finally reached Program 8. And Program 8 is for logarithms. In this case, they're natural logarithms rather than base 10 or anything else. So the program is launched in the normal way by pressing 8p, and then it'll clear all the memories. Then I enter the number I want to convert into a logarithm and press the ln key, which is shared with the memory star key. I'll set the decimals to its maximum of 9 by pressing 9 and the ds key, and engage the floating point. Then enter my number. I'll go for 13 and press the ln key. You'll notice that the calculator pauses while it works it out, and we get the result of 2.564949,357 with the letter L next to it, so that we know it's a logarithmic value. But it can also convert a logarithmic amount back into a true number by pressing the EX key, which is shared with the M key. It still only works for natural logarithms, of course. So if I enter 7.601,402,3346 and press the EX key, it will have a think about it for a while and then come up with the answer of 2001 with the letter E next to it, not indicating an error in this case, but an exponent. Last but not least, if you're in a program and you want to go back to using the machine as a normal calculator, you could turn it off and on again, but it appears to work if you press P and now the program is cancelled. That whole lot has taken longer than I expected, so I'll wrap up now. If you've enjoyed watching, please like the video and maybe even subscribe to the channel, not forgetting to click on the bell icon so you get notifications when future videos are released. That's it for now, so thanks for watching and I'll see you in a future video.